So I want you to imagine a small, armored, robotic tank.
Yeah.
Right? Driving 64 kilometers into deeply hostile territory.
Which is, a massive distance for any unmanned platform.
Exactly. And it's not just a casual drive. It is taking direct artillery fire. Enemy drones are dropping munitions on it from above. It even hits a landmine, triggering this massive explosion.
Oh, wow.
Yeah. And despite all of that, it just keeps moving. And ultimately, it brings a severely wounded human soldier back home, alive.
It sounds totally fabricated, honestly.
Right. It sounds like a scene from some sci-fi movie. But it is a very real event that actually happened last year in Ukraine. But, the actual revolution here isn't just the robot itself. It's the agonizing, muddy, and just incredibly complex reality of keeping that machine running in basically the worst conditions on Earth.
Yeah, and it completely upends the expectation we have of modern combat. Because, when people think about the battlefield today, their minds usually go straight to the sky.
Right, the drones.
Exactly. Aerial footage gives us this sleek, removed, almost cinematic perspective of war. But down in the dirt, there's this paradigm shift happening that is far more gritty and, in many ways, far more consequential.
Which is exactly our mission for you today on this deep dive. We are pulling all our insights from a single, just intensely practical source today. It's an article from the Modern War Institute titled Networked for War: Lessons from Ukraine's Ground Robots.
Yeah, written by Jorge Rivero.
Right, Rivero. And his background is super interesting. He's a retired Marine, an explosive ordnance disposal technician, meaning, he used to literally disarm bombs for a living. And he's a Russian foreign area specialist.
His background is crucial here, I think, because he looks at this technology not as some academic in a sterile lab, right? He looks at it as someone who really understands the mud, the friction, and just the sheer frustration of operating machines under fire.
Absolutely. So we are going to explore how unmanned ground vehicles, or UGVs, have rapidly scaled from these scrappy garage experiments into absolute battlefield necessities. And more importantly, we want to uncover what it actually takes to keep these systems from just becoming, extremely costly paperweights.
Because that's the real challenge.
Yeah. Okay, let's unpack this.
Okay.
Because the sheer scale of the deployment happening right now is just difficult to wrap your head around.
The acceleration really is unprecedented. To understand why this matters to you, the listener, you really have to look at the numbers.
Hit me with them.
Okay, so in 2024, the Ukrainian defense industry delivered roughly 2,000 unmanned ground vehicles to their frontline units.
2,000, okay.
Fast forward just 1 year to 2025, and that number jumped to 15,000.
Wait, 15,000 ground robots in a single year?
Yeah, entirely logistics.
The article notes that the 3rd Assault Brigade, they use these UGVs for 80% of their logistics operations. And in heavily contested cities, places like Pokrovsk and Myrnograd, that actually jumps to 90%.
Which makes sense when you think about the mechanics of an infantry unit. Logistics is essentially the blood and nervous system of a military force.
Right.
If the muscle, the human soldiers, doesn't get a constant supply of calories, water, and ammunition, it just stops moving. And historically, soldiers had to carry all of that on their backs.
Which is exhausting.
Right, meaning a human could only haul so much weight before physical exhaustion basically rendered them combat ineffective.
Well, the source mentions these UGVs can carry up to 450 pounds on a single run.
Yeah, 450 pounds.
So instead of visualizing some futuristic cyborg, it's more accurate to picture an automated pack mule that just never gets tired. It's like an Amazon delivery bot trying to navigate an apocalyptic wasteland.
And I have to ask, is this just about giving soldiers a heavier automated backpack, or does this fundamentally rewrite infantry tactics?
What's fascinating here is the direct mathematical outcome of offloading that weight and risk. The Ukrainian General Staff is reporting up to a 30% reduction in personnel casualties.
30%, that is huge.
It's massive because the core operational doctrine they're developing, it isn't about replacing the human soldier. It is strictly about keeping the human out of the kill zone whenever possible.
Right, which drastically slows down the degradation of your fighting force.
Exactly.
The 30% casualty reduction just by automating the supply runs. But, if you're listening to this, you're probably wondering about that soldier I mentioned at the very beginning of the show, the one who got rescued. Because that goes beyond logistics into medevac, which I imagine changes the psychology of the battlefield entirely. Oh, absolutely it does. The case study Rivero highlights from the 1st Medical Battalion is a perfect example of this. They use a UGV called the MAL to retrieve that wounded soldier 64 kilometers deep behind Russian lines.
64 kilometers. I still can't get over that.
It's a grueling journey for a machine.
And the detail that stood out to me was how the soldier actually survived the journey. The robot was fitted with this specially designed polypropylene armored capsule.
Right.
And I actually had to look into why they would use polypropylene instead of just, bolting heavy steel plates onto the robot.
And what did you find?
Well, it turns out polypropylene is incredibly lightweight, meaning it doesn't drain the robot's battery nearly as fast as steel would. But more importantly, it's non-magnetic.
Ah, of course.
Yeah, so it is far less likely to trigger certain types of magnetic landmines. And on top of that, when it gets hit by shrapnel, it tends to absorb the fragments rather than spalling or shattering like certain metals do, which would create secondary shrapnel inside the capsule.
That is just brilliant engineering. That combination of material science and automation allowed a mission that previously would have been considered a complete suicide run.
Yeah, nobody would have gone out there.
Historically, sending a human medevac team that deep into denied territory, you risk losing 4 more lives just to save one. Knowing a machine can come for you, it alters the morale of the troops, and it changes the calculated risk a commander is willing to take.
We also see this kind of shift playing out in engineering and demining, right?
Yeah.
The article discusses this Ukrainian firm called Rovertech. They're producing a demining platform called the ZMI.
The ZMI, yes.
It clears 7,000 square meters a day, and it paces infantry assaults at 4 kilometers per hour, meaning the soldiers don't have to stop and lose their momentum to, physically probe the dirt for mines. They just walk right behind the robot.
And Rivera makes a huge point here. The ZMI only costs $20,000 per unit.
Hold on, $20,000?
Yeah.
For an average person? That's the price of a used Honda Civic. How is that considered a cheap, disposable piece of equipment for a military?
Well, you have to look to comparative cost. Analogous systems in the U.S. procurement pipeline, they can run into the millions of dollars.
Millions?
Oh, yeah, because they are engineered for absolute perfection. They want them to be indestructible. But the ZME is engineered for volume. If that $20,000 piece of metal hits a massive anti-tank mine and is literally vaporized...
You haven't lost a human.
Exactly. You haven't lost a highly trained human engineer, and you haven't lost a multi-million-dollar asset. You just push the next $20,000 robot forward and maintain the tempo of your assault.
Okay, so if you're listening to this and wondering, I'm wondering, if these machines can haul 450 pounds, cut casualties by 30%, and pace a whole infantry assault, why isn't every military on Earth completely automated by now? What is the catch?
The catch is what Rivero refers to as the video game fallacy.
The video game fallacy.
Yeah. We see these sleek, heavily edited clips on social media, right? And we assume operating a UGV is as simple as picking up a PlayStation controller and driving around.
Right, like playing Call of Duty.
Exactly. But in reality, the psychological and technical friction of driving one of these things under fire is just agonizing.
He illustrates this so beautifully with a story from his own deployment to Afghanistan back in 2013. He was operating a Talon robot, and he was trying to inch it down this shallow ravine toward an IED, an improvised explosive device, basically a hidden roadside bomb.
Right.
And he says, in a video game, driving a remote-controlled car down a small dirt hill, it takes maybe 10 seconds. It took him 40 minutes.
40 minutes.
Yeah. 40 minutes for a small ravine.
And the mechanism causing that delay, it's the total loss of depth perception. You see, humans rely on stereoscopic vision. Because we have 2 eyes, our brain triangulates distance instantly without us even thinking about it.
Right.
Try closing one eye and catching a baseball. It becomes incredibly difficult.
I can't even imagine. And the robot he was driving, it only had fixed cameras.
It had 4 grainy camera feeds. And when you compress a complex 3-dimensional physical environment into a flat 2-dimensional screen, you completely lose the ability to judge scale.
So everything looks flat?
Exactly. A small dip in the dirt looks like a massive crater, and a sheer drop-off just looks like a gentle slope.
Here's where it gets really interesting. Picture yourself in that scenario. You are staring at a screen, trying to drive this machine through a rocky ditch, but it's like trying to look through a foggy straw.
That's a great way to put it.
You have no top-down view. You have to constantly stop, switch between the 4 cameras, and try to painstakingly build a 3D map in your own head. And the entire time you're doing this, your human team is sitting in a vehicle, totally exposed, just waiting for you to finish.
And that exposure is the hidden vulnerability of the whole system. Rivero notes they eventually had to raise a sensor mast on their own armored vehicle just to get better situational awareness of where the robot actually was. And by doing that, they immediately gave away their own position to the enemy.
Just to see their own robot. And that was Afghanistan in 2013 against an insurgency. If you add the modern Ukrainian theater into the mix, you have to deal with total communication collapse.
Total collapse.
Rivero explains that simply driving the robot around the corner of a building or down into a deep ditch, it breaks the physical line of sight for the radio waves, and the signal just drops.
Gone. And even when you maintain perfect line of sight, the electromagnetic spectrum itself is incredibly hostile over there. Electronic warfare is really the invisible terrain of modern combat. The Russians are constantly blasting the entire area with electromagnetic noise just to overwhelm the receivers on these robots.
He explicitly mentions Starlink in the article. And we all think of Starlink as this magical, high-speed space internet that just solves everything, right?
Right, the ultimate failsafe.
But the Russian jamming is so intense that the connection speed is frequently forced down to as little as 10 megabits per second. 10 megabits.
It's nothing.
You would struggle to stream a standard definition video on your phone with that connection, let alone pilot a machine through an active minefield, relying on multiple live video feeds.
And that bandwidth choke is exactly why onboard sensors and autonomy still aren't enough to solve the problem by themselves. If the link back to the human operator is severed or degraded to a trickle like that, the robot simply stops. It just sits there and becomes a target.
The article also brings up this concept of electronic fratricide. Now, I get the general concept, you accidentally jam your own team, but how does that practically happen when these military networks are supposedly so advanced? Don't they know what frequencies their own robots are using?
In a perfectly sterile environment, yes, of course. But in a chaotic firefight, infantry units are absolutely terrified of being hit by enemy attack drones.
Right, understandably.
So what do? They turn on their own portable electronic jammers. And these jammers often blast broad-spectrum noise, meaning they just jam a wide swath of frequencies just to be safe.
They just flood the zone.
Exactly. So if the unit operating the ground robot isn't perfectly coordinated with the infantry squad right next to them, the infantry's jammer completely blocks the signal to their own ground robot. You effectively shoot down your own equipment with invisible waves.
Wow. So let me get this straight. We have isolated robots that are practically blind because of the 2D screens, and their signals are constantly being choked out by enemy jamming or even friendly fire.
Yep.
That seems like a complete dead end. How are the Ukrainians actually making 15,000 of these things work on a daily basis?
Because they stopped treating the ground robot as an isolated platform. Rivero points out that the only viable solution to all of this is the robotic strike group. You have to move from a single piece of hardware to a networked team of machines.
Okay, so we're essentially talking about a Voltron-style approach.
Yeah.
You take the ground bot, the air bot, and the jammer, and you plug them all together into a single squad so they can cover each other's blind spots.
If we connect this to the bigger picture, this is the massive hurdle for traditional militaries. The challenge for the U.S. right now isn't building a robot with thicker steel armor or faster tracks.
Right.
The challenge is designing the software architecture and the tactical doctrine so that aerial drones, ground vehicles, and human infantry function as a single, combined arms network from the absolute moment they are deployed.
Rivero breaks down exactly how this integration actually solves the video game fallacy.
Yeah.
Remember that agonizing 40-minute drive down a ravine?
Yeah.
Well, to fix that, the ground robot pulls its targeting and navigation data directly from an overhead quadcopter drone.
The aerial drone provides that stereoscopic top-down view that the ground operator is missing. It acts as an eye in the sky. And furthermore, it solves the line-of-sight radio problem.
Oh, right, because it's up high.
Exactly. If the ground robot drives behind a brick building, the signal from the operator bounces up to the aerial drone and then straight down to the robot. The drone basically becomes an airborne relay tower.
That's incredibly smart. But then you run into the next problem. What protects the ground robot from being destroyed by Russian attack drones? Because the ground robot is completely exposed from above.
Well, this is where the physics of the platforms dictate their roles. Aerial quadcopters are really limited by weight, right? They can only carry so much battery power before they just can't lift off the ground. Ground vehicles, however, can carry incredibly heavy payloads. So the strike group networks the UGV to carry all the heavy electronic warfare equipment.
Oh, I see where this is going. The article notes they are outfitting these ground robots with directed energy weapons, like high-energy lasers or high-powered microwaves. And the mechanism there is that a laser requires a massive, heavy battery pack to generate that kind of heat.
Right, you need serious juice for that.
And you can't put a 200-pound battery on a small flying drone, but you can easily strap it to a tank tread on a ground robot.
Precisely. The ground robot becomes a mobile air defense battery for the whole group. It blasts microwaves into the sky to fry the circuitry of incoming enemy drones. They are even employing AI-enabled gun turrets, like a system called the Sky Sentinel, to provide local air cover.
The synergy is just incredible when you lay it out like that. Robot A is hauling 450 pounds of ammunition. Robot B is driving right next to it, blasting a high-powered microwave field into the sky to protect them both. And Robot C is a drone hovering 1,000 feet up, providing the map and relaying all the communication signals. And they're all talking to each other in real time.
Yeah, because no single machine can survive that environment alone. But a modular group can adapt to almost any threat. But, getting those machines to actually talk to each other, getting the AI to reliably recognize a Russian drone versus, say, a bird that requires an absolute ocean of data.
Which brings up a massive strategic advantage. Rivero points out that by partnering with Ukraine, the U.S. military is gaining access to millions of hours of raw combat footage and telemetry data.
Which is invaluable, because you cannot train a combat AI model in a laboratory.
Right.
Synthetic lab data just doesn't account for the chaotic reflection of radio waves off a ruined building, or exactly how a tank track slips in freezing mud. Ukraine is generating authentic, messy, real-world data at an industrial scale.
And he explicitly states this partnership could accelerate U.S. research and development by several years and save billions of dollars. Because, like you said, you simply cannot fake the electronic noise of a real war zone.
You really can't. But there is a physical limit to software. All the AI, all the lasers, and all the network data in the world cannot save a robot that hits a physical landmine or just snaps an axle in a muddy trench.
Which leads us to the final and honestly probably the most unglamorous part of this entire deep dive, the physical maintenance. Because how do you keep a network squad of robots running when your supply chain is literally being shelled by artillery?
You have to completely decentralize your maintenance model. Rivero contrasts the old U.S. methodology with the reality of what Ukraine is forced to do today.
The old U.S. model. I mean, reading about it during Iraq and Afghanistan, It is mind-boggling. He notes that if an EOD team had a broken Talon or PackBot, they would routinely just put the broken robot in a box and mail it back to the manufacturer in Massachusetts.
Yeah.
Mailing a robot from Afghanistan to Massachusetts, thousands of miles away from the front line.
Well, in a low-intensity counterinsurgency where you have total air superiority and secure massive logistics bases, you can sort of afford that kind of inefficiency.
Sure.
But in a high-intensity peer-to-peer conflict, relying on a depot on another continent, that would completely cripple a brigade's combat power in a matter of days.
So what does this all mean?
Yeah.
The analogy that comes to my mind is that imagine your smartphone screen shatters while you're in the middle of a high-stakes street fight. The old model demands you mail the phone to a factory in another country and wait weeks. But the new Ukrainian model is like having a fully equipped mobile Genius Bar parked in the alleyway right behind you.
I love that analogy. And that mobile Genius Bar is the absolute key to their operational tempo. Rivero details how Ukrainian brigades now embed 10 to 12-person engineering workshops directly on the zero line, right inside their unmanned systems battalions.
And these aren't just guys swapping out AA batteries, right? These frontline workshops are equipped with 3D printers. They are fabricating custom replacement parts on demand. If the Russian military deploys some new electronic jammer on a Tuesday, these frontline mechanics are rewriting the software configurations and changing the frequencies on their robots by Wednesday morning.
The feedback loop is completely closed. The operator brings a damaged unit back, explains exactly what failed under what specific condition, and the engineer just fixes it in hours.
There's this fantastic detail in the source about the Lithuanian Riflemen's Union. They actually designed a mobile repair vehicle specifically for these unmanned systems.
Oh, the repair truck, yeah.
Yeah. It only costs $36,000. It holds 2 technicians, a 3D printer, welding gear, and it can run completely autonomously for 2 days. They literally drive this truck to within a few kilometers of the fighting, just to weld tracks back onto robots.
Because without that immediate decentralized maintenance, an advanced robotic strike group just devolves into a collection of highly expensive, disposable, one-shot systems. You would burn through a stockpile of 15,000 robots in a matter of weeks.
This reality leads to Rivero's major policy recommendation for the U.S., doesn't it? He argues that the military must ditch the highly profitable contractor model and mandate a right to repair.
Yes. Traditionally, complex military hardware is maintained by field service representatives. These are civilians working for the defense contractors who own the proprietary tech.
Right.
Rivero argues that if a system goes into a modern war zone, soldiers must have the legal right and the technical training to pop the hood, 3D print a part, and rewrite the software themselves without asking some corporation for permission.
He even suggests creating short, tactical electronics courses, like taking a standard infantry soldier and giving them a secondary specialty. So the person holding the rifle is also entirely capable of diagnosing a blown motherboard in a muddy trench.
It entirely collapses the distance between the person operating the machine and the person fixing the machine. If you are saving human manpower because robots are doing all the dangerous supply runs, you have to reinvest those human soldiers into these forward technical roles.
It requires a total rewiring of how a military institution functions. Which, I think, brings us to the core takeaway for you listening today. Why does a deep dive into Ukrainian ground robots matter to someone who isn't actively serving in the military?
Because it serves as the ultimate case study in how disruptive technology is adopted in any field. It proves that innovation is almost never just about buying a new gadget and dropping it into an old system.
Yeah, you can't just buy 15,000 robots and declare the problem solved. The technology forces the human institution to evolve around it. You have to invent entirely new ways to push data through jammed networks. You have to completely change the educational pipeline for mechanics. You have to rewrite the fundamental doctrine of how human beings move through a forest.
Exactly.
If the human systems don't adapt, the technology is basically useless.
What's fascinating here is how this adaptation changes the very nature of risk. Rivero makes the critical point that robots will inevitably assume the missions where exposure to enemy fire guarantees human losses. They are taking over the guaranteed death scenarios.
Which leaves us with a final thought we want you to mull over after the show. If we build on that exact premise, if future militaries adapt so successfully that they reach a point where they have a reasonable expectation of zero human casualties for their most dangerous frontline operations, how does that fundamentally shift the geopolitical threshold for deciding to go to war in the first place?
It's a heavy question. Historically, the political cost of initiating a conflict is measured in human lives. If frontline casualties are reduced to twisted metal, melted polypropylene, and fried motherboards, does the decision for a nation to initiate a war become alarmingly easier?
It is a profound and honestly a chilling thought to explore. That silent, unglamorous revolution happening right down in the mud might just alter the mathematical threshold of human conflict forever. Thank you so much for joining us on this deep dive. We'll catch you next time.
Thanks for listening.